I would like to, I went through your website, and let me show that. Let's see here, share the screen, that one, go. All right, I think I'm sharing. This is your website, Flat Earth Intel. And I went through this to try to understand what you were talking about and what your data was. You talk about the 45-degree sector test on here.
Mm-hmm.
So let me try to then reiterate back to you my understanding of what the test is and why that shows what you say it shows. All right. Okay, I have a little PowerPoint slide for that. I'm not going to do a whole thing, just, okay. And now I got to share that screen. Let's share that. Okay, so let me break it down if I can. The gist is this. It is your basic globe model as we understand it. I'm not trying to like presuppose this or whatever. I'm trying to say this is what we've been told, and the 45-degree sector test is based on our understanding of this model. So this is supposed to be the Earth here. I got the equator tilted at the 23 degrees that we know it is, and the sun is like way far off to the side. I just drew a sun here so that we understand the sun's coming from this side. So the sun shines onto the Earth, and there's one spot where it is perpendicular to the surface. Oh, and by the way, Corey, if I say anything that's totally wrong, just stop me and correct me. So where on the Earth that hits depends on the time of year. And I should clarify, at different times of year, it hits at a different latitude. So I've drawn a latitude line here that is the exact latitude that the sun is hitting. So at noon, at this spot, the sun is straight overhead at 90 degrees. All right. So anywhere else on the Earth, like further north, if we go further north of that latitude, the sun, being so far away, shining parallel light, will be at less than 90 degrees. And so I summarize that here. I say, if you're outside the tropics, right, this is the tropics, anywhere outside there, the sun can never get to 90 degrees.
That's
right?
correct.
Okay.
In the model, yeah.
Yeah, according to the model. Okay, and at local noon, the sun is at 90 degrees at one spot on the Earth. Okay, so that's here. And if you're north of that spot, it will be less than 90 degrees. So the 45-degree sector test comes in, and that says that same thing we just said, that the sun is directly over something I'm going to call the subsolar point. I think you had a different name for that, but we'll call it the subsolar point for understanding. Mm-hmm. And at noon, it's at 90 degrees above that point, like we just showed. Anywhere that is not that same latitude, the sun must be lower than 90 degrees. So I drew that here. And then I make the statement. Anywhere that is not the latitude of the subsolar point, anywhere other than this yellow dotted line, the sun is always lower than where the sun is at that latitude, because this is the highest the sun can get. 90 degrees is straight up. You can't get any higher. So if you're lower than that at noon, then you're going to be lower all day long.
So let's, you're doing great so far.
Okay.
Why is that? In other words, that's a limit. We're talking about a limit now, a geometric limit. So now we're talking about, I call the terminology line of parallel. It's just
now,
like
you did. Let me pause. Did you mean these lines, these yellow lines that I have? Is this lines of parallel?
So that 90 degrees, okay, your first, where the sun makes contact with the Earth, that's your first line. Okay, that's your first 90-degree line. Okay, so not to throw you off. Okay, so let's just say in the heliocentric model, I'm going to take this object, okay?
Oh, hold on. Let me tab out so I can see you. Go for it.
And this is probably the easiest way to explain it to people. In the heliocentric model, this is my sun. Now, if I'm in the tropics, the sun is what? It's right over my head, okay? So it's straight up above me. This is me, and it's straight up above me, okay? So I'm 90 degrees. I always tell people, you can do this practical exercise at home. This is real easy. And we'll do the flat Earth, we'll do the globe model, and we'll do the flat Earth model. So if I take this object, and this is my pointer we're going to talk about the globe model first. See if I can get my.
Well, I don't want to interrupt you. Can you just clarify using the diagram that I have? Is that not clear enough, my diagram?
This will help it. This will give it a little bit more relevance. Okay. And you'll understand because I've talked to people who had a hard time with it and they didn't understand it. So this seems to work. In other words, this seems to help.
They seem to understand your approach.
Yeah.
Okay.
So this
see if I can give you solo. No, that's me solo. I want you solo. I don't know how to do that. Okay, go ahead.
Okay. So I'll try and get the alignment. So let's just say this is me. Now I'm going to use both my arms. So I hold this object directly over my head at 90 degrees. Okay. Because some people say, well, I don't understand why it can't be more than 90 degrees at 45 degrees. Okay. Here's why. Now on the globe model with my other arm, this is my pointer arm. I have this arm to the ground. I bring this arm halfway up. At 3 hours on the globe model, I am oriented. In other words, I'm standing at 45 degrees to the sun. Okay. So that is my surface angle. That is my observer surface angle. I've just lost half my sky pointing at the sun because of the time at 3 hours. So now I am 45 degrees to this object that is 90 degrees. Remember, this object is always 90 degrees when it's tilted and you're in the summer. So I've just lost half my sky. So now I'm at 45 degrees. So what do I have left to make 90 degrees? I have 45 degrees. So between here and here, I only have 45 degrees. So I can come up anywhere in here is fine. My pointer comes up. So I'm halfway up. I start from 0 all the way up to 45, and I'm pointing at this object. I have to be on alignment with this object at 40. That's the maximum.
Right. Well, we didn't get to the 45 yet.
No, I'm just telling you. Okay. So once I exceed that limit, I'm off the sun. In other words, I'm no longer on alignment with the sun. I'm coming off it.
Right.
That's the globe model. That's why I only have 45 degrees to work with in the globe model. The flat Earth model is different.
Okay. Well, before we get to the flat Earth model, can let's summarize this one. I have a time slot for the
go ahead. Okay, go ahead.
Okay.
And I don't know if that clarified it for you, but that it seems to work for people. They seem to understand it a little bit better.
Okay, I can appreciate that. This is my first time trying to explain it to people, so maybe your way is better. I'm putting the sun over here, and so I'm saying that at noon it's at. Whoops, I'm in the wrong presentation. So unprofessional. Okay, at noon it's shining straight on at this point, and so if you're up here, it must be lower than that. And this is the highest point it will be. This is noon, so this is the highest it will ever get at your location. For the rest of the day, the sun's going to go down after this point, right? So if the highest it ever got was something less than 90, then I say...
All right, go back to that.
Okay.
Go back. Yep. So you have to remember, you're out of the prime meridians, you're out of the prime or the tropics.
You're out of the tropics.
Remember, the 90, you can only get in the tropics between your lines. So when you talk about 90 above it, you ain't going to get 90 above it at that, because again, you're out of the zone. You're out of the sun's operating zone for that model.
Good. And I did want to, I'm glad you brought that up. It's a bit of a tangent, but in your videos, I heard you refer to that as the prime meridian zone, but I think you meant the tropics.
Yeah.
I understood that from your
Some
description
of it. Equatorial plane. I got even flatter. Well, that's the equatorial plane. Okay.
Right. Between the two tropics.
Yeah.
Right? Good point. Very good point. So if you're north of the northern tropic, south of the southern tropic, the sun will never get to 90 degrees. If you're in between there, then it's only at 90 degrees twice a year. Right?
So here's, if you take a look at your diagram, I want you to think of the globe as they say it rotates or it spins, okay? So do you remember the old phonographs before they came out in like a disc? They were kind of like on a roller. So think of that as a roller, as a contact point. And that spins, and that sun is always 90 degrees. So as it's spinning, that's just that contact point. So it's spinning one way, or it's spinning, and then it goes back. It comes up towards the north, and then it goes back towards the south, back and forth, back and forth. That's all. That's how we, in the heliocentric model, that's how we get our seasons.
That's cool. All right. Yes. Very good. Very good.
Yeah.
Okay. So the next point that I say here is the Earth rotates, according to the heliocentric model, at 15 degrees per hour. And that means that causes the sun to move exactly 15 degrees per hour. Well, almost exactly 15 degrees per hour in the sky, regardless of the time of day. And the sun then, the sun sets at 15 degrees per hour, right? And so in 3 hours, so I want to talk about afternoon, but it's true before noon as well. 3 hours after noon, that's 3 times 15, right? So that's 45 degrees. The sun has traveled 45 degrees in 3 hours. So 3 hours after noon, the sun should be 45 degrees. It started at 90, right? At the subsolar point, right? At the subsolar point, the sun was at 90 at noon. So 3 hours later, it should be at 45. We agree on that?
So now, when you say the sun travels, you're talking the flat Earth model.
No,
Are you a hiding flat Earther, Matt?
No, I'm saying the sun moves across.
So as the orbit, or as the Earth orbits or turns, the observer is now oriented. Their angle to the sun is at 45 degrees.
Yes.
That's a big difference.
That's a better way of saying it, but yeah.
Because people have a hard time with that. And they say, well, what do you mean? No, in your model, the Earth turns or rotates. So now that's how you rotate.
Right. And so what we say then is that,
and you can say,
when you measure the altitude of the sun, right? You measure the altitude angle to the sun is what you're going to do. Yeah. It should be, according to this description, if you're at the subsolar point, the sun should be at 45. But the big key is we're not at the subsolar point. You're north of that, right? And so it must be lower than 45.
45 or lower. It can be 45. You can be at 45 degrees and you're fine, but that's the limit.
45 is the absolute limit, right? For anywhere on the Earth, right? You're saying. But the farther away from the subsolar point, the less you're expecting that to be.
Exactly. And that's just the distance. Distance is also going to work against that.
Okay, and so that leads to point number 8 here, the final point, which I'll blow up. 45 degrees is the highest the sun can possibly be 3 hours before or after local noon anywhere on Earth. Agreed?
Well, I wouldn't say anywhere on Earth now. Because again, when you make that statement, what if I'm in the tropics?
Well, the 45 is the highest it could be.
Okay.
If you're at the subsolar point 3 hours after, according to what we just talked about, right?
Well, we're not, as the observer, we're not, because we're what? We're 3 hours from the subsolar point. In other words.
Well, yeah. You're right. And that is confusing.
Yeah.
I am saying very specifically,
have to remember
3 hours.
We're across
3 hours after it was noon there.
Right. We're across the sector.
Right. Right. Okay. And so then the last thing, and I do want to show this because it was on your website. I couldn't make out the numbers, but you shared them with me. So thank you very much for that, by the way, being very forthcoming. I want to make sure my audience hears that Corey is not hiding anything. Corey shared the data, and here's what you shared. I picked out some of your best, I thought what your best observations were. And this was from Kabul, Afghanistan. And there's the dates. And you took them all right at 3 p.m. And I looked up what solar noon was, and I added that to your chart. And then I noted just that it is all more than 3 hours past local noon.
So how did you get solar noon? Where are you getting that from?
I just looked that up on the good old internet.
Okay, we're going to talk about that.
Okay, we can definitely talk about that. That might be what you were talking about with the sun survey point, which is next up. So then these are the angles that you measured, and you can see, even though we're more than 3 hours after noon, the sun is higher than 45 degrees, right? And because of that, based on the logic we just did, that's impossible on the globe model, according to the logic we just did, right?
That presents a problem.
Okay. Before I go any further, let me just posit to you. There's two possibilities. Well, there's three possibilities I see here.
Sure.
Number one, the globe Earth model is wrong. That's the one you suggest. Number two, the logic we just went through is wrong. Or number three, these measurements are wrong. Right? Now, I have already looked, and so these measurements are not wrong. Your measurements are right. I will say they're all within 1 degree. I'm going to grant you, I'm not going to argue the measurements. They're within 1 degree. And so with that margin, we're at 48 degrees here. So there's plenty of room. It's that one's gone, right? So there's two possibilities. The globe model is wrong, or the logic we just went through was wrong. Fair?
I would agree with you. I would agree with you. Yes.
Okay. Something else I want to point out while we're looking at the chart, because I noticed this was in the summertime.
Right? Why is it in the summer?
Why is it in the summer? I noticed that, and I noticed that it's. Are you asking me why do I see that it's in the summer, or why?
Yeah, why do you understand it's in it? Do you understand why it's in the summer?
Because it's the 19th of June, and the summer solstice is the 21st, 22nd of June. Where's
the tilt at?
Oh, I guess technically that makes it the spring, but it's approaching the summer solstice, I should say.
All right. So that's what we want to, because if we take readings, now I took readings, I think when I started in February. So the sun's going to be, you're going to have that. Remember when we talk about, the heliocentric model, the Earth, it tilts, okay, towards the summer, and then tilts away as you go back into the winter months. That's how you get your seasons in the heliocentric model. So when we apply that, we want to look at summer, or when the sun is up, tilted towards when the Earth is tilted towards the north, when the sun, because when we tilt, there's a new section in the front 45, which I have the off-axis tilt. Okay.
All right. So
maximum is 23 and I think a half degrees. So that's why we have those summer readings. Okay. That's what's going to tell us the story. And now we have some people I think that are going to do this test in Australia in that summer, because I'm interested in the southern hemisphere. We have readings up in the north. I have them from Southwest Asia, and I have them from the US. Now, both those sectors have failed for the globe model. So now we have two sectors with major geometric failure. Now I'm interested in getting readings from other people who learn how to do it and what their information is from the south in the southern hemisphere. So we're going to get more information as time goes on.